Welcome to Physical Science Module 7b. We'll be talking about Earth's thermal energy. Here's your vocabulary list. Be sure to record it and write in your definitions. Thermal energy is energy from the sun, and thermal energy affects Earth's weather. The light that comes to Earth is called insolation. This word insolation comes from thermal energy, or energy from the sun, affects Earth's weather. The light that comes to Earth is called insolation. Insolation is a word formed by pieces of other words. Incoming solar radiation. So we call this insolation. The amount of insolation Earth receives from the sun is affected by two factors: Earth's distance from the sun and Earth's axial tilt. If Earth's average distance from the sun were different by just a few percent, life as we know it could not exist. We've talked about this many times. Earth does not orbit the sun in a perfect circle. The path that Earth travels around the sun is a slight oval called an ellipse. Here's an example of Earth's orbit around the sun. Earth doesn't just hang in space completely vertically. Instead, Earth is actually tilted in space about 23%. This tilt is what causes Earth's seasons. So how does this work? Let's just take a quick look at this drawing. And we have along the Earth's path here, you'll see what they call the spring equinox and the autumn equinox, summer solstice, winter solstice. These are terms you've probably heard in movies or related to weather, and now we will find out what that means. So when Earth is at its aphelion, which is the furthest distance from the sun, when Earth is at its aphelion, it's the furthest distance from the sun. When it's at its perihelion, it's closest to the sun, and it receives about 3% more insolation than it does on average. So of course, the closer we are to the sun, the more radiation we receive. Aphelion is the point at which Earth is farthest from the sun, and perihelion, the point at which Earth is closest to the sun. When Earth is near its perihelion, it is winter. When Earth is near its aphelion, it is summer. So the closer the sun is to the Earth is our winter. The further it is from the Earth is our summer. That can create a lot of questions. To make a somewhat long story shorter, you can watch a video from one of my favorite YouTube sites. This gentleman has a really professional site. It's called Today I Found Out. And in case you'd like to check this site out, it gives you a more thorough and entertaining example of what being closer or further from the sun means. Not only is Earth's axial tilt responsible for our seasons, but the tilt is also responsible for the fact that the seasons are reversed between northern and southern hemispheres. So when it's winter in the northern hemisphere, it's summer in the southern hemisphere. Also, while the Earth orbits around the sun, it's also spinning on its axis, turning day into night and night into day. When a region of the Earth is pointed toward the sun, it receives light, and that's what we call daytime. When it's pointed away from the sun, there's no light, and that's nighttime. It's usually warmer during the day because insolation is hitting that region of the planet. Nights are typically cooler because the region is getting less insolation. As we know, days get longer in the summer and shorter in the winter. The days are longer in the hemisphere that points more directly to the sun. The days are shorter in the hemisphere that points away from the sun. June 21st or 22nd every year is called the summer solstice. That's the longest day of the year. At this point, every part of the northern hemisphere sees the sun for more than 12 hours, and every part of the southern hemisphere for less than 12 hours. June 21st or 22nd, we actually call the summer solstice. At this point, every part of the northern hemisphere sees the sun for more than 12 hours a day. So, consequently, the opposite happens when we have the winter solstice, which comes around December 21st or 22nd. The southern hemisphere is then pointed directly at the sun, and we see the reverse of the summer solstice. The northern hemisphere has less than 12 hours a day, and the southern hemisphere has more. There are 2 points in Earth's orbit where the axial tilt is not relevant. Neither hemisphere is tilted toward the sun, and both hemispheres have 12 hours a day and night. They occur on March 20th or 21st, and this is the spring equinox. The autumnal, I probably messed that up, autumnal equinox is on September 22nd or 23rd. So the Earth's axial tilt causes its seasons. The tilt determines when the seasons change. The timings of the seasons would change if Earth had a different orbit. Earth's elliptical orbit also affects the amount of insolation the Earth receives. As we learned from the video, as you will have learned from the video that you could have watched, because land heats more easily than does water, the northern hemisphere heats more easily than the southern hemisphere. Another fact, because the Earth's tilt, besides the Earth's tilt, that influences the Earth's temperature, is cloud cover. So the Earth's tilt can influence temperature, but also cloud cover can have a lot to do with it. Clouds actually reflect insolation, keeping the thermal energy from hitting Earth. Consequently, the temperature lowers. Hopefully this helps, and hopefully you've gone and watched that other video. If not, we probably will in class. If you need any assistance, be sure to contact me. God bless.